Hello, this is a microcontroller powered watch I have made. As you can see, it can show the time, date, day of the week and the voltage on the internal rechargeable battery in millivolts. It goes to sleep after about 4 seconds of being in clock mode to conserve power, but I can make it stay in clock mode by just pressing the button again. It also has a calculator mode. For this I need to use an infrared remote to input the numbers and commands. So we can try something simple like 2 times 2. It can do several calculations at a time, such as 2 plus 2 times 2. And as you see, it follows the correct order of operations. We can also do powers and decimal powers, such as 2 to the power of 0.5, which will give a square root of 2. And of course, you can do any kind of operation with decimal numbers. So, for example, let's try something which looks hard. And we can also do brackets to make it do calculations in our own order of operations. It also has a graphical calculator mode, where it can draw 2 graphs at a time. Let's try with something simple like y equals x squared. It shows the scale here, and I can zoom in and out, and you can see that the scale changes. So let's try drawing 2 graphs, such as 2x cubed and minus 1, and the second graph, let's do a linear one, y equals 2.1 x plus 1. And we can zoom in and zoom out. You can also do x to the power of 4, for example. So it can do pretty much any kind of polynomial where there is x to the power of something. Let's try x to the power of 0.5. Oops. Well, here it's confused. It doesn't know what to do, but you can see that this is the correct graph for y equals square root of 2. We can also do y equals x to the power of minus 1. And we can zoom out. It can also do exponentials, such as 2 to the power of x, or 3 to the power of 2x. So these are all of its features. I will show you the inside now. This case is made of sheet copper, which I cut out and soldered. And here is a display, an LCD display. This is the real-time clock module, which keeps track of the time. It has its own backup battery, and it switches to this battery's power when there's no power coming from the lithium-ion battery. The microcontroller is on this Arduino Pro mini board. It's an Atmega 328P, and here you can see those pins where I can connect a USB to serial converter to plug this into a computer and program it. I'm using the Arduino IDE for programming it, which is basically C language. Here there are 3 buttons. All of them are connected, but the program that is running now only uses this button. This is a global switch for powering down the device. This is the infrared receiver for collecting commands from this remote. This is an LED, which at the moment isn't programmed to do anything, but it is connected so it can be programmed to light up. I'll show you the underside. So here's the removable backup battery for the real-time clock, and the bottom is finished with hot glue so that the wires don't get damaged. And in order to charge the lithium-ion battery, it's actually from a Nokia phone. I can take it out like this. I put it inside the Nokia and I charge it. And here on the underside of the display you can see the microcontroller chip and some connecting wires.